Hi, hello, welcome to Homeschool. This is your class 9 Mathematics NCERT or CBSE board. We are in our chapter 6 constructions. Before we start our construction, we should know about what are all the geometrical instruments used to construct these figures. In geometrical box, we have some instruments. What are all those? You can see this one. You may call it as a scale or you may call it as a graduated scale. To do a construction, we mainly need two instruments. One is, this is graduated scale. We use ungraduated scale, and also we need compass. You can see this one. To do any construction, minimum things we need here is, you are going to take this and this one. What are these? Graduated scale and also compass. Sometimes we may use protractor in some constructions. In our geometrical box, what all will be there? You can see scale and you can see two triangle shaped ones. What are those two? Set squares. Pair of set squares. And what are the angles? Both are right angles. Both are right angles means it is 90, 90. One of the angle for this set square is 30 and other angle is 60 degree. Whereas for other set square, look here, both the other angles will be 45 degree. You may call this set square as a right isosceles triangle also. And next one, protractor. You can see protractor. Already we have discussed about this in lines and angles chapter. Look here. There you have a point here. You can see two lines, two curved lines. It makes a straight angle. One scale starts from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, so on up to 180. And in the same manner, reverse order. 0, 10, 20. Why? Two scales you have here. Suppose if you are measuring this side angle, then you can put your protractor here. From here 0, 10, 20 like this you can measure and you can draw the angle. Suppose you need to check the angle this side. This side means you can't put the protractor here. Understand carefully. You cannot put the protractor here and you cannot make the angle. Then at that time you need to take the protractor and keep like this and then start measuring your angle from here 0 to. Always we need to measure the angle from 0. Here you can go with this scale, and if you place here, you can go with this scale. Suppose if you place here, you can go with this scale. Right? So always you need to understand the line. Always you should measure your angle from a line segment. You need to put the point, the center point you need to place here, and you need to measure your angle from the line segment. Suppose you need to measure this side angle, put your protractor this side center, adjust on the top of this point and then measure the angle. Compass. See here, you can see a compass here. One side you can say a sharp point and another side there is a provision to make a pencil inside it. Right? One side a sharp edge point and another side pencil end point will be there. You can adjust the radius of this compass and you can make circles or arcs and all. Right? What is the name of the instrument? Compass. Divider. You can see here divider. There is no provision for any pencil. Only two sharp edges will be there. You can adjust its radius and you can measure and you can use this instrument. Once again, what are all the geometrical instruments will be there in your geometrical box? A graduated ruler or a graduated scale you can write, graduated ruler you can write, pair of set square. set squares will be having an angle of 90, 60, 30 and another set square will be having 90, 45, 45. Protractor to measure the angle, compass to draw the circles or curves or arcs, and you can have a divider, right? Eraser, pencil, these are all no need of mentioning. These are all the geometrical instruments which will be there in your geometrical box. Yes, we are going to see all the instruments from your geometrical box now. See here children, you can see this. What is this? It is a ungraduated scale where it have all the measurements. We use in this construction mainly two instruments. One is ungraduated scale or ungraduated ruler and compass. Sometimes we may use protractor also. You can see here some measurements on the scale. Using this, we are going to draw the line segments. And next, this is one of the set square. See here how it is. It is a right angle at one side and other two angles are 45 degrees. One more set square you can see here. 90 degrees, 60 degree and 30 degree. Now, what is this? It is a protractor. You can see two scales. One from 0 to 180 and another from 180 to 0. And now, we are going to see the divider. You can see the divider here. You can adjust how much you want. Yes, adjustment there for this divider. Two sharp endpoints are there for this. And next comes to your compass. You can see here one side it will be having a sharp endpoint and another side there is a provision to make a pencil inside it. But whereas this is a construction tool I use for board, so I use a provision for chalk piece. Right? These are all the geometrical instruments we use in this constructions. So you should know all names, children. These are all the names. You should be perfect. So once again, graduated ruler, and this is a set square of having 90 degree, 45 degree, 45 degree angle. And this set square will have one angle is 90, another 60 and another 30 degree angle. And this is called as a protractor. And next, divider. Look here, this is the divider. And last, you can have compass. Now, we are all familiar with all the geometrical instruments in the geometry box. Now, in this construction chapter, that is your chapter number 6, what we are going to construct in this chapter? You can see here 3 points. Perpendicular bisector, angle bisector, constructing an angle using ray. Let's see. Perpendicular bisector. Just let's have a hint of the bisectors here. I'm going to take a line segment of length 8 centimeters. Mark point A and B on the end point of your line segment. Draw a perpendicular bisector. What is the meaning of perpendicular bisector? Perpendicular 90 degree. Bisector. It divides equally. Whereas we have taken a line segment. What does a perpendicular bisector will do? It divides the line segment equally. Suppose it is 8 centimeters, right? When a bisector is drawn, it will be divided into 4 and 4 centimeters. How to draw this bisector? Let's take here compass. 8 centimeters, right? More than half we need to take. What is your first step to draw perpendicular bisector? More than half. Put the sharp edge at any one point. If I put at A, above one arc, below one arc. Don't disturb this measurement. And again, put the sharp edge point at B, above and below. Cut the arc. From point A as center, more than half as a line segment measure. Draw above an arc and below an arc. With the same measurement, put B as the center, cut the arcs. Now you can see the intersecting points here, two arcs intersecting point, right? Take a scale and then you are going to join this line. This point exactly divides AB line segment into half. That means 4 centimeters and 4 centimeters. If you want, you can draw and check this bisector. Right? Next, coming to angle bisector. How to do angle bisector? Let me draw an angle here. Okay. AOB. AOB is having an angle 40 degree. Draw angular bisector, I say. What you are going to do? You can take any measurement. So from O as a center. O as a center with some measurement. What you are going to do? Join the two arms of the angle. Right? Then where the arm touches the rays. From here, this as a center, draw a arc. Lift this compass and this as a center, cut the arc. Where the two arcs intersect from that position to O. Using scale, you can draw a ray. See here, this exactly divides an angle 20 degree, 20 degree. Right? This is the way we need to construct the angular bisector. And your third one, constructing an angle using a ray. Suppose if I take a ray means one end point is a point and another side it is never ending ray will be there. Right? One side of a line is having an end point and another side is never ending. It is called as a ray. So using this ray, construct any angle. How can I construct the angle using a ray? Okay, fine. So let me construct 90 degrees. Observe here children carefully. Draw a ray of some measurement. Any measurement you can take. Mark O and this is A. I am going to construct now 90 degree angle using this ray. So now put the point here, right? Take some measurement, little, no problem. So what you do? You go like this, right? Now, where the semicircle is started from ray, that point onwards, same measurement, don't change your measurement. 1 and again where it intersects the semicircle, from there cut this. Look here children carefully. When you draw any semicircle from one end point, what happens? With that same measurement, again you lift your skiver or compass. You can put the point here. Again draw the arc. If you are able to join this intersecting point to this point, you are going to get an angle 60. Second arc, if you want to join this point O, it will be 120. Then where will be the third arc? Suppose if you extend your semicircle, you can see here carefully from this intersecting point, it will be 180. So observe here carefully, 60, 120, 180 means it will be on this straight line. So now 90 degree angle I said I am going to make. 90 degree, how you are going to get? 60, this is 60, this is 120. 60 and 120 degree, middle angle is 90. So now with the same measurement, look here, from 120 degree intersecting point there to and again from 60-degree intersecting point there, both you are going to draw two arcs. Where these two intersect, from that point you just try to join the point. Yes, this is the angle which you need to form using a ray. How much angle you are able to frame here? 90 degree. Suppose 60. If you want 60, look here, from this point to this intersecting point, join. This angle is 60 and this angle is 90. Look here, this angle is 90. And if you want to frame 120, from this intersecting point, join, extend, frame a ray, and this angle will be 120 degree. This is just the hint I have given for you. Once again, let's have a look of all the three concepts, what we are going to do in this chapter. Ready? Perpendicular bisector. Given line segment, first you draw a line. Then more than half using your compass. More than half take the radius and then above and below draw the arc. Then with another point as a center, cut the arc. Where the two arcs intersects, try to join the line. What you get, it is only the perpendicular bisector. Coming to your second concept, angular bisector. How can you get angular bisector here? Suppose if you take any angle, right? You can draw any angle. For that angle, you need to bisect an angle such that it divides equally. I have taken here 40 degree angle. With some radius from O as center, I have drawn a curve which touches the two rays of the angle. Then again, where it touches from there to, I have drawn an arc and another point on another ray. Cut the arc, try to join. That is only the angular bisector which divides the angle equally. And your last concept is constructing an angle using a ray. Draw a ray. First you try to draw a ray and you first confirm how much angle you need to draw. I said here I want to draw 90 degree. So 90 degree from the point, line segment end point, you draw a semicircle with the same measurement, draw the arc, right? First arc indicates 60 degree. From that arc again draw arc on semicircle, right? That arc will be 120. If you want to draw 90, you just imagine where is 90? In 120 and 60 middle will be 90. So for these two angles, you need to get a bisector. So from here, draw an arc, cut the arc, join, you are going to get the 90 degree angle. Exercise 6.1, first problem. Construct an angle of 90 degree at the initial point of a given ray and justify the construction. So we need to do a construction creating an angle 90 degree. Before starting this, we just undergo with a tiny introduction here. Suppose if I draw a ray. Ray means, you know children, what is that? One is end point and one is never ending. Now from this point with convenient radius, I am doing a rough figure. For every construction, we need to do a rough figure and we need to understand how can we draw this construction. With this point as a center, convenient radius. With some convenient radius, draw an arc. So some radius I have taken here. With compass, you need to do this. Okay. Some arc I have drawn. Now lift your compass and the sharp point, put the point here. Suppose if you mark with the letter A, B is a ray. With A as a center, convenient radius, draw an arc. If that arc touching the ray at a point C. Now lift your compass and put the compass at a point C. With the same radius, don't try to disturb children. With same radius, draw an arc, cutting the before arc. Now mark this point as D. Now again lift your compass, put the point D as a center, do one more arc. Now try to understand here children, when I take the compass, this radius and this radius will be same. If I try to join, I get an equilateral triangle. Equilateral triangle, all sides are equal, all angles are equal. All angles equal means each angle is how much? 60 degree. Yes or no? 60 plus 60 plus 60 will be 180 degree. Now, this arc, from first arc intersecting point, if I try to join A, then what does the angle it is created? It creates an angle 60 degree. Right? Now with the same measurement, we have drawn one more arc. This is 60. Then what it will be? Again it will be 60. If you try to join from this intersecting point to A, then this angle will be 60. 60 plus 60 will be 120. Yes? Now, I don't want 120 degree. I need 90 degree. Where is 90 degree lying? 90 degree is lying in between 60 and 120. So now lift your compass, put this point as a center, right? Draw an arc above. If you want same radius, you can take. Lift the compass and put the point at here E and then cut the arc. Mark the intersecting point as F. Mark the intersecting point as F. Now where the intersecting point there, F, from there to A, join and frame a ray, G. Now the angle created here is 90 degree. How? 60. In 60 degree angle, one bisector is divided here. Right? I have done an angular bisector. So it creates the angle equally. This angle will be 30. Now from here, if I start measuring, 60 plus 30 will be 90 degree. What we need to show is that one only. Show or construct angle 90 degrees. How did we do, children? Once again, try to understand. This is just a rough figure. Every construction, we need a rough figure. Right? Later, if you want, you can clean up or you can keep aside in rough column also. Once again, how did we do this? Draw a ray AB. With A as a center, convenient radius, draw an arc. Right? With the same radius, lift your compass, put the sharp point at C and cut the arc on a before arc. Right? So it intersect at point D. Then again lift and put sharp edge at D and cut the arc again. With the same measurement, it cuts at E. From E and D, try to draw an arc and cut the arc. Then it creates a point where it intersects a point F. From F, join AF. Extend the line to get a ray. Extend the line segment from here to here end given, right? Try to extend this to form a ray. Now what the angle it is created? Angle GAB is equal to 90 degree. That is the construction we need to do. So if you want, once you can have a look of your steps also, same manner it will be. You need to write steps for every construction. Let us read steps, then do the original construction. Draw a ray AB at the point A. From the point A, I have drawn a ray. Taking A as the center and a convenient radius, your wish. You can extend your radius like this but take a fixed radius. and draw an arc which intersects AB at C. Next step, taking C as a center and with the same radius, draw an arc which intersects the previous arc at D. And next step, similarly, taking D as a center and with the same radius, draw an arc which intersects at E. Now, taking D and E as a center, draw arcs with equal radius or more than half of the radius. You can take measurement. If you want, you can change, but take same radius from E and D. Next step, which intersects at F. Mark this point as F. Draw a ray AG. Try to join this and then extend. You are going to get a ray AG. Angle GAB is the required angle of 90 degree. Angle GAB is the required angle for 90 degree. Right? Suppose now here itself you can create three angles, children. How? Same arc. If you try to join and extend a ray, you get 60 degree angle. Okay? And if you draw a ray from here, you get 120 degree angle. If they ask 90, 60 and 120 middle intersecting point, you are going to get 90. Now, if I ask you 30 degree, how can you get 30 degree? I know 60 degree, right? From this point and this point, if you try to intersect a point, you are going to get 30 degree angle. Understand carefully. If you intersect these two, look here, these two if you try to intersect, you are going to get 30. And if you join this, 60. And again, 60 and 120 intersecting, middle intersecting point will be 90. Right? Like this, try to understand the angle, how I need to do, and then try to start. Now, for this problem, you need to construct, write the steps and give your justification. Justification later we are going to see after our construction. Let's do the construction here. First step. What is your first step? Draw a ray. Take a sharp pencil, sharp and dark pencil, A, and mark a point here. And this is B. First step is completed. Draw a ray from a point A. Draw a ray AB from a point A. Second step. Taking A as a center with convenient radius. Okay, let me take this much. And now, it's difficult on board, but you can draw nicely in your notes. Take a convenient radius and draw an arc. Right? Now, where does the arc touching ray? Mark this point as C. Same measurement, don't try to change anything. From this point as a center, draw an arc cutting the before arc. Mark this intersecting point as D. Okay? Now again, same radius. Don't disturb your compass. From D as a center, draw one more arc. If I try to join, what angle is created here? 60. If I try to join, what is the angle created here? 120. Right? Now, I need to draw 90 degree. How can I draw 90? Let's mark this intersecting point as E. Mark the point E. Now, with your same radius, from D and E as a center. D as a center, have drawn an arc. Now, with E as a center, cut the arc. What did I do? Let me join and then repeat the steps. Take scale. Now mark this intersecting point as F. Take a scale and a sharp pencil. Draw a ray and mark this point G. Now, what is that we have done? We have constructed an angle 90 degree. Where it is? Angle GAB. This is your perpendicular angle. Yes or no? This is your perpendicular angle. Construct means this much is completed. But now they asked us to justify a justification. How can we start a justification? Just join AE. Where is AE? Join. Okay. Justify the answer they asked. Let's start a justification. Join AE, AD, CD, DE, FE and FD. Look here. AC, AD, AE, ED, CD, DF and EF. All this we join with a dotted lines. If you want, you can extend these two. If you want, you can extend and to get a race. Right? Now, consider this triangle here. What is your first triangle? Triangle AC, triangle ACD. It looks like an equilateral triangle. AC is equal to AD is equal to CD. How? If you want, you can check here. AC, AD and CD all are equal. So, if all sides are equal, what it is? It is an equilateral triangle. If all sides are equal, then their angles are equal. All angles means how many? 3 angles are equal. 3 angles, each angle is 60 degree. This is 60, this is 60 and this angle is 60 degree. Okay, I will take only this angle. What I need to prove this is 90, right? Only this angle I take and I mark it as first equation. Similarly, what you can take? Take triangle ADE. Take triangle ADE again. What did I say? This is 60. Again from here to here it is 60. It will be there. Means 120 degree. This angle it is created. Right? Now, all these 3 sides are also equal. Then it forms an equilateral triangle. Then this angle is also 60 degree. Right? 60, 60, 60. If you want, you can write or just you can skip the step. 60, 60, 60. All angles are 60. Now, one step is we have proved this is 60. And another, this angle is 60 we have written. Now from 1 and 2, what I can say? ADE, alternate angles and this angle equal to this angle I have said. Now consider triangle AEF and triangle ADF. You can see the triangles now here children. Same triangles AEF and ADF. I say that AD is equal to AE. Why? Equilateral triangles, all sides are equal. AD is equal to AE. And now DF. DF is equal to EF. These two sides are equal in equilateral triangle. Again, DF is equal to EF. How we are saying? You have taken the same radius. Same radius you have drawn while you are cutting the arcs. Right? Therefore, these two distance is also same. Then I say AF is equal to AF. It is a common side. That side is common. By S congruency rule, I say that the two triangles are congruent. Which two triangles? Triangle AEF is congruent to triangle ADF. If these two triangles are congruent, then the by CPCT corresponding parts are equal. So which corresponding parts we are going to take? I take this angle equal to this angle. That is angle EAF is equal to angle FAD. Yes or no? These two angles are equal. If these two angles are equal, what I can say? These two angles are half of the angle EAD. This is half of angle EAD. What is angle EAD in triangle AED? This angle is equal to 60. Half of 60 degree is equal to 30 degree. Half of 60 means 30. So, this is 30 and this will be 30. Finally, final step I just write here. Finally, angle GAB, or you can write FAB also, no problem, is equal to angle GAD plus, or you can write, if you feel you are confusing, you just write FAB, FAD you can write. Or if you no confusion means you can use with G also. Angle GAD plus angle DAC. What is angle GAD? 30 degree plus angle DAC 60 degree. So if you add, angle GAB is equal to 90 degree. So finally when we are doing construction, we get it is 90. How we get 90? We need to justify, means this is the method to justify a construction. See the second problem. Construct an angle of 45 degree at the initial point of a given ray and justify the construction. Same manner how we have done 90, similar pattern. Let's see the rough figure here. Draw a ray from a point A. Draw a ray AB from a point A. Okay. Now with your convenient radius, with A as a center, draw an arc. Now touching the ray at C. With C as a center, same radius, cut the arc. Mark this point as D. Again from D as a center, draw one more arc. Mark this point as E. Now from E and D as a center, more than half, draw the arcs intersecting point to draw a ray. Mark this intersecting point as F. Now what did we construct? We have done 90 degree angle, but we need 45. How to get 45 degree? 90 degree half is 45 degree. Yes or no? Half of 90 is 45. If we able to draw 90, then 45 is very easy. Now look here carefully. This perpendicular 90 degree angle where it touches, mark this point as G. Right? Now this arc and this perpendicular where it touches, that point is important. Now here, more than half from here, draw an arc. And here, same measurement, same radius, cut the arc. Now, intersecting point, mark H. Try to join from A, draw a ray, right? Now, the angle which is created, this angle is 45 degree. Understand the question carefully. What we need to do? We need to construct an angle 45 degree. 45 degree means first you should get this point. Half of 90 is 45 degree. So first quickly we create an angle of 90 degree. Now 90 degree where the arc touches from that point and from C point, draw the arcs and intersecting point join A. The angle which is created, that is HAB angle, is equal to 45 degree. Construction steps you can see there. How can you justify your answer? It is very easy. How can you justify? If you try to join this all, if you consider AGH triangle and ACH triangle, AC is equal to AG and CH is equal to GH. AH is a common side. By SSS congruency rule, you can say the two triangles are congruent. By CPCT, I can equate these two angles are equal. If these two angles are equal, what I can say? This is half of this angle. Only this angle if you consider. Right? Both the angles are equal. Then half of the big angle is this one. That is, this angle is 90. Half of 90 is 45 degree. Rough figure. By drawing a rough figure, you got the idea. Same rough figure. See the construction steps and then we go for the original construction. Draw a ray AB at the point A. Yes, AB I have drawn a ray. Taking A as center and a convenient radius, draw an arc which intersects AB at C. Taking C as a center with the same radius, draw an arc which intersects the previous arc at D. Now, similarly, taking D as a center and with the same radius, draw an arc which intersects at E. Taking D and E as a center, draw the arcs and try to join and intersecting at F. From the point A, draw a ray AF which intersects arc DE at G. Taking C and G as a center, draw arc with equal radius which intersects at H. From the point A, draw a ray AH. Okay. Now, angle HAB is a required angle of 45 degree. Let's draw the construction and then justify our answer. Now, let's do the construction by drawing a ray AB. A, mark a point here, B. Now, what's your second step? With A as a center, convenient radius. Okay. I have drawn an arc where it touches AB at a C point. Now, from C as a center, draw an arc and mark this point as D. And now with D as a center, mark a point E. Now from E and D as a center, try to intersect and mark that intersecting point. And mark this intersecting point as F. Okay. And now try to draw a ray from A and F. What is the angle created here? 90 degree. Now see the line or the ray where it touches the arc you have drawn now. So this point, mark it as G. Now more than half. More than half means see here. More than half you can take. Right? So from G and C as a center. G and C as a center. Right? I have drawn G as a center one arc. And from C, I have cut that arc. Now, try to join these two and then extend to get a ray. See carefully, A point and mark this point as H. Now, right? Now, what we got, this angle is 45 degree angle. Now justify our answer set. How do we start our justification? Justification. Before explaining your justification, once again have a look of your construction. Have a look of your construction. What did we do? How did we do? Draw a ray AB from point A. Okay, with your convenient radius, draw an arc. Where the arc touches AB, mark it C. Now with C as the center, same radius, draw the arc, mark point D. Then again another arc, mark point E. Now D and E as the center, draw two arcs which intersects. And this angle which is created is 90 degree. I need to create an angle 45 degree. 45 degree means half of 90, right? So again, where this arc touches the point on the perpendicular, that point and this point you consider more than half. Draw an arc and cut the arc intersecting point to A, extend, form a ray. The angle so created is 45 degree. It is very easy. Look here children, try to understand carefully. Now after completing all angles, at a stretch in one figure itself, I show you all the angles. Okay, try to practice carefully and draw carefully. Yeah, justification. Join. What shall we join here? GH and CH are having same radius. Now, join GH and CH. Consider the triangle. Which triangle we take? AGH and ACH. Consider triangle AGH and triangle ACH. AGH and ACH. Now compare these two triangles. AG is equal to AC. Same radius we have taken, right? By construction you can say same radius you have taken. Next, AH is equal to AH, common. AH is equal to AH. That side is common for two triangles. And now GH is equal to CH. Why? Same radius, I have drawn the arcs. Same radius. Therefore, finally what I can say, by SSS rule, I say that triangle AGH is congruent to triangle ACH. If these two triangles are congruent, what you can say, by CPCT, their angles are equal. Which angles? By CPCT, I equate angle GAH is equal to angle HAC. Angle HAC. But I need only this angle, right? So complete angle is how much? 90 degree we know. Angle GAC is equal to angle GAH plus angle HAC. Now both are same set. I equate both as HAC. Same angle now, I need this angle. So this angle also I equate with HAC. Angle HAC plus angle HAC. What is angle GAC? 90 degree. And 2 times, let's do here, 2 times angle HAC is equal to 90. Send this multiple other side. Angle HAC is equal to 90 degree by 2. If you cancel, you are going to get 45 degree. Therefore, angle HAC is equal to 45 degree. Hence, it is proved. We did not say 45, but we were able to prove this is 45 degree. Right? Understand carefully. Suppose the same arc here. See carefully from here. If I join, it becomes 60. If I join here, it becomes 120. And this is 90. Now you created 45 degrees. Right? With this, we are going to end our session today. In our next session, we are going to complete this exercise. Until that, practice these constructions carefully. Thank you all.